Hello students, we are going to start with space curves. I will draw a figure, x-axis, y-axis, z-axis, and suppose that you have a curve something like this in the space. This is your gamma. Assume that gamma is unit speed. Then, as usual, the curvature of gamma is defined as kappa equal to norm of gamma double dot of s and the curvature measures how far the curve deviates from being a straight line. Okay, so that straight lines have curvature is equal to 0. Now for space curves there is another thing which is also important. For example, this is a straight line in R3 and its curvature is equal to 0, but this is not a plane curve. This straight line, okay, this straight line is a plane curve, of course, it lies in a plane. But suppose you have something like this, here the curvature is equal to 0, here also the curvature is equal to 0, here also the curvature is equal to 0, but this is not a plane curve. So at certain points curvature is equal to 0, but this is not a plane curve. So there is another measurement which is important in space curves, which is called torsion. So torsion is a quantity which we are going to define in a moment, which measures how far a curve deviates from being a plane curve. For example, you have the circle in the xy plane. This circle in the xy plane. This circle, this is a plane curve, so its torsion must be equal to 0. So for plane curves, torsion is equal to 0. Must be equal to 0. So this quantity we have to define formally. For that, I have started with a unit speed curve. Unit speed. So T dot, T, which is equal to gamma dot. This is a unit vector, which is the tangent vector. And I will define, okay, look at T dot. Okay, I will define another vector, vector n. Vector n is equal to 1 by norm of gamma double dot of s into gamma double dot of S. Okay, what is gamma double dot? It is P dot. So this is precisely 1 by, what is this? This is the curvature, kappa. 1 by kappa into gamma double dot is P dot. So this, so what is the magnitude of this vector? This is a unit vector. N is a unit vector. Now look at T and T dot. Norm of T is equal to 1 because gamma is unit speed. So this is the unit tangent vector. So norm of T is equal to 1. This implies that T dot is perpendicular to T. That means T dot inner product T, that is equal to 0. This means that 1 by kappa times T dot, that is also perpendicular to T. That means N is perpendicular to T. This implies vector N is perpendicular to vector T. Okay. Now I am going to define another vector. Vector B equal to, let us say, T cross N by definition. This is called binormal vector. N is called normal vector, unit normal vector. Let us observe what is the magnitude of B. Magnitude of B equal to magnitude of T into magnitude of N into cosine of the angle between, not cosine, sine of the angle between T and N. But N is perpendicular to T, angle is pi by 2. So sine pi by 2 is equal to 1. So norm of B equal to, or magnitude of B, that is equal to 1, because T is of magnitude 1, N is of magnitude 1, and sine pi by 2, that is equal to 1. Therefore this B is actually called a unit binormal because its magnitude is equal to 1. Okay. Now look at B dot. What is B? B is T cross N by definition. So B dot, that is equal to T dot cross N plus T cross N dot. Okay. But what is T dot cross N? What is N? N is in the direction of T dot. N is equal to 1 by kappa T dot. Therefore N and T dot, they are in the same direction. So T dot cross N will be equal to the 0 vector. This is equal to the 0 vector plus T cross N dot, which is equal to T cross N dot okay. Also B is of unit magnitude, therefore B dot is perpendicular to B. B dot inner product B is equal to 0. Now look at B. B is perpendicular to both T and N. B is perpendicular to both T and N. And B dot, that is also perpendicular to B. dot is perpendicular to B, or B is perpendicular to B dot. Let us write in that way. B is perpendicular to B dot. So B is perpendicular to B dot. This is because B has magnitude is equal to 1 always. Therefore, B must be it's not like that. Just a second. B dot is perpendicular to T. B dot is T cross N dot. So B dot is perpendicular to T. Also it is perpendicular to B. Yes. Look at B dot, not B. B dot is perpendicular to T from this equation. From this equation, let us say this is equation A. From equation A, B dot is perpendicular to T. Also B dot is perpendicular to B. B dot is perpendicular to B. Therefore, B dot and N, they must be parallel because you are in R3. Therefore, B dot, there are only three mutually perpendicular directions in R3. Therefore, B dot is parallel to N. Parallel to vector N. Therefore, B dot, that is equal to a constant times, I will put a negative sign here, tau S times vector N, and this tau S is called the torsion. This tau S is called the torsion. Remember where we started with? We started with gamma is a unit speed curve and N is equal to 1 by norm of gamma double dot of S. So here, to make this sense, this must be non-zero. This is precisely curvature. So all these discussions is valid when the curvature is non-zero. So torsion is defined only for, thus torsion for a space curve of non-zero curvature, that is important. Non-zero curvature is defined as defined by means of this equation, or tau S is equal to minus B dot inner product with vector N. How did you get this? Because you are taking inner product of both sides. With respect to N. So here I will get B dot inner product n is equal to minus tau s n inner product n, but n inner product n is equal to 1. So tau s is minus B dot inner product n. So this is the formula for torsion. Thank you.